So the notes for today is just kind of an extension of what we just quizzed on yesterday. So, or I guess it would be on Tuesday now, or Monday. But it's just now putting together the distance formula and now being able to find perimeter of figures, which you've certainly have done at some point in your life. But typically they probably weren't shapes that weren't rectangles or squares where we're just adding up the sides. So you'll see here we have a quadrilateral, triangle, and then a circle. Go through these three, and then give you the homework. It'll be pretty similar, 3 questions, and hopefully it won't take too much of your time there, and something that you can handle pretty reasonably. So it wants you to find the perimeter of each figure below, and then it says round your answers to the nearest 100th, which will be our second decimal place. So perimeter wise, it's just adding up the lengths of all these sides. So we want to know what's the length of the side from A to B, what's the length of side BC, CD, so on and so forth, and then we just add all those up. So basically what we have here is you have your two options. We could, if we want, if you have this point and this point, we could label point B as the point, 2, 6, and we could label point A as the point -5, 2. And then you could do your distance formula with that, which is what we just quizzed on. So that's one option. The other option would be to do your Pythagorean theorem, because if I go from A to B, let me do this in red, we can make a right triangle out of this in order to go from A to B, and then we would know that this triangle is a right triangle. Here's our 90-degree angle. We would have a length of 1, 2, 3, 4 here. And then over here, our length would be 1, 2, 3, 4, 5, 6, 7 here. Since this is now our right angle, the hypotenuse is what we're going to be looking for. So we could also set up a Pythagorean theorem problem and do 4 squared plus 7 squared equals, and then this is our C, that's what we're trying to find, is the hypotenuse, that long side, equals your C squared. So if we did that, you're going to get 16 plus 49, and then that would equal C squared. We could then add those guys together to get a 63 equals C squared. And then at this point of the year, I think we probably all know we can get rid of that squared by using that square root key. So on our calculators, we would do the square root of 63. We want to go to the nearest 100th, so that's our second decimal, and we would know that's 7.94. All right. So that's what this one is. So let me change this. Instead of having a generic variable, we can now actually say that this has a length of 7.94. So now what would make this easy is if this is a parallelogram, which is kind of what we get into here the next few days, again, revisit that, then we know opposite sides are congruent. So it would be nice if we knew this side was congruent to this side. Remember what those little tick marks mean. So here's an easy way to kind of test that. Go from C to D. So here's C. I'm 1, 2, 3, 4. And then I go 1, 2, 3, 4, 5, 6, 7 to the left. So notice how we get another right triangle. Just like we had this right triangle up here. We have a length of 4 here and a length of 7 here. We'll look at the previous triangle. Notice how one length was 4, just like this one is. The other length was 7, just like this one was. Well, if we have these two that are congruent, think about, wouldn't we just be setting up the exact same equation that we had just set up here? And if we did that, the only thing that could play out are the exact same 3 steps afterwards, which would tell us then, since their 2 legs are congruent, 4 and 7, 4 and 7, that would mean the hypotenuse would also have to be congruent, so we would know very quickly that this is 7.94. That is why I like using the Pythagorean theorem with these, so that if you see that we have 2 lengths that are the same, the 2 legs are the same, then we're going to be able to pretty quickly know that these are congruent, and we don't have to go through all the work, whereas if you did the distance formula, so if we would have done the whole x2 minus x1 squared, plus the y's subtracted from each other and then squared, you would get the same thing. So you're going to get 3 squared, which is 9. Sorry, let me correct that. This was a negative 5. So this is a negative 7 squared, which is 49. And then this would be a negative 4 squared, which is 16. Notice how you still get the square root of 63. So we're going to get the same thing, but the Pythagorean theorem will allow us to figure out that these have the same length. So right now, our perimeter, we're going to be doing 7.94 plus 7.94, but then we have to figure out the other two sides. So same thing, let's make a right triangle. From this point to point A, D to A, we're going to go left 1, 2, and then we'd have to go up 1, 2, 3, 4, 5, 6. And then we're looking for the hypotenuse here, which is C. So if we set up another little Pythagorean theorem problem, 2 squared plus 6 squared equals our hypotenuse squared. Simplifies down to be 4 plus 36 equals C squared. Add those together. Use our square root key. So we're now doing the square root of 40. That is 6.32. So we can now go back here. We now know for sure that this side is 6.32. And then we want to know, are these congruent? Is this length here going to be congruent to this length here? So when we form this right triangle, to get from C to B, I go up 1, 2, 3, 4, 5, 6. Notice how this 6 has the same length as this triangle's leg. And then I'm going to go left 2, 1, 2. This was the length of this leg. So if these two legs are 6 and 2, and we got this as our length, then I can now know if I have a 6 and a 2 here, another Pythagorean theorem problem, we would know that this is also going to give us 6.32. So we add those two, throw that into our calculators, and we should get a perimeter of 28.52. All right. So distance formula is fine. You still want to know that, but we also did a little review of the Pythagorean theorem. Really, these are the same. If you remember correctly, the distance formula is basically the Pythagorean theorem with you solving for your C. 2, not a quadrilateral, so we won't be able to do it quite that easily. This time we will have to do it for each of them. So let's do E to F. So I'm going to go, do this in red, 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7. All right. Let's save ourselves a little bit of time, right? We just did a right triangle up here where I had a length of 4 and a length of 7. So if we were going to set this up, you again would just be getting all of these exact same steps. So in a right triangle, if I know one leg is 4 and one leg is 7, we could set all that up again if we wanted. 4 squared plus 7 squared equals C squared. But what should happen, that's a 4, we should get the same exact thing that we got above. So 63 equals C squared, just like it did right here. Take your square root, and we know that's 7.94. So that's this length. If I'm going to go from G to F, make a right triangle, 1, 2, 3, 4, 5, 6, 7, 8 steps up, and then 1, 2 steps to the right. So now this is unique. This we're going to have to do a Pythagorean theorem for this one. 2 squared plus 8 squared equals C squared. Square each of these. So 4 plus 64, 68. Take the square root of both sides. And we see that that length is 8.25. Last one is from E to G. So I'll go from E to G. I'm going to go down 1, 2, 3, 4. And then 1, let me mark that. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. These are unique. We haven't done a right triangle yet with a length of 4 and a length of 9. So this is one we'll set up. So 4 squared plus 9 squared equals your hypotenuse squared. Square each of those. What is that? 97. And then we see that our C is 9.85. We can then come back over here, know that this length is 9.85, and then we add all of those up. So the 7.94 plus the 8.25 plus the 9.85, all added up. Give me a minute here to plug those in. Should give us 26.04. So that's that perimeter. All right. Last one. You have learned this. I don't know if you would have used this word necessarily, but when we are looking for the perimeter of a circle, it doesn't have sides, obviously, like this triangle does and like this quadrilateral had. A circle doesn't have sides. What we have is just this perimeter, and this perimeter is always equidistant from the point H. So 1, 2, 3 away, 1, 2, 3 here, 1, 2, 3. That's our radius. Okay, all that good stuff with circles. So when we are talking about the perimeter of a circle, a little review here. The perimeter of the circle is, if we were in school right now, I'd give a nice long awkward teacher pause to see if anybody remembered what this is called. All right, but the perimeter of a circle is called the circumference. So whenever we're finding the circumference of a circle, what we're really looking for is what's the length all the way around this circle. If we could basically extend that out, turn that into a straight line, maybe separate it here. All right, pull that apart if it was a rope, straighten it out. The circumference is basically your perimeter. How far around the circle do you go? I would then probably ask, all right, since I know you have all learned this at some point in time, what is the circumference of a circle? See if we remember that. The circumference is 2 pi r. Sometimes we would have said pi times your diameter, because twice the radius is your diameter, so you may have seen this both ways, or one way or the other. I am preferential to this guy, the 2 pi r. So for this circle, we would do 2 times pi. Look at your radius here. So here's the center. We are 1, 2, 3 units away in every direction from this point. 1, 2, 3 units away. 1, 2, 3. So our radius is 3. Sometimes you may be asked to write it in terms of pi. That's the exact answer. Since your directions here were to round to the nearest tenth, you would find the pi key on the calculator, and we would say that our circumference, which is really just our perimeter, that's what a perimeter of a circle is, we would say is 18.85. All right. That's pretty much it. Just a little extra on top of what you did with the distance formula. Again, we can use the distance formula up here for all of these, these sides. I do think the Pythagorean theorem is probably a little bit simpler, a little bit easier for most of us to understand. Understand also that the Pythagorean theorem and the distance formula are very much related, okay? Yeah, so we covered that in our last lesson. So with that, I'll bid you adieu. Have a good day, and the assignment should be pretty darn similar.